Hello everyone and welcome back to part 2 of the Kotlin extension functions tutorial. In this video, we'll take a look at how we can mock Kotlin extension functions and demonstrate how they greatly simplify the testing process in comparison to Java. In order to mock anything, we first need to install a mocking library. We're going to use Mockk in this video because it was built with Kotlin in mind. Mock's official website is mockk.io. It contains a wide range of usage examples, but for now we're just interested in installing it. We can search for it in Maven Central. I've already included it as a test dependency in my project. Just copy this line into your Gradle build file and make sure that the dependency has been downloaded. To work with extension function mocks, we'll just create a simple class that consumes a big decimal and we'll pretend that it actually does something important, but for our purposes, we'll keep it as simple as possible. So I'll call this big decimal extension consumer. And as I said, we're just gonna pretend that this actually does something useful, but for simplicity, we'll simply use it as a proxy to our extension functions. So I'm just gonna create two methods, one called useInteger, which will just use the integer part extension function, and one more method that uses the fractional part. So now we can move on to the mocking part. I'm going to create a new test. In using Mockk, we can override the behavior of an extension function using the Mockk static method. And in this case, we want to override the behavior of big decimal integer part. And we want every big decimal with a value of 5. When its integer part method is invoked, we want it to return a big decimal of 129, for example. And we can test that this actually is the case. By invoking the useInteger method of our simple example here on top of a big decimal with a value of 5. And we want the result to be equal to 129. And this test should pass. Okay. In addition to this, we can make sure that invoking the integer part on a big decimal different than 5 works as expected. So we're going to do this. And the test should pass as well. Alright, and we can also implement a similar method for the fractional part. But we're dealing with an extension property in this case. It doesn't matter, we can use it just like we did in the extension method case. So again, if we provide a big decimal of 5, we want to receive a result of 129. We're going to use the fraction method in this case because it's actually the one that relies on the fractional part extension property. And I'm going to comment this for now. Alright, and we can also make sure that the fractional part still works as expected for big decimals that are different from 5. In this case, the answer should be 0.12. And the test should pass once again. Let's also take a look at another common operation when it comes to mocking. and that's making sure that a particular method was actually invoked. So we're going to once again mock one of our extension functions, the integer part, and I'm going to create a specific mock that's a big decimal using the mockk method, and this mock is going to be relaxed because otherwise mockk will complain that we are invoking a method for which we have not provided a definite return value. So we're going to use our consumer with our input, and we can verify that our input had its integer part invoked. And this test passed, so if we comment this line out, the test should fail. So what about the Java case? Again, let's pretend that there's some sort of a consumer for our static methods. And it's just going to proxy to the static method extension functions. Okay, but how do we mock this? One approach would be to use something called power mock to mock static methods, but I won't show that here because we generally want to avoid static methods in the first place. But we'll take into consideration the fact that we might be working in a company that has a bunch of static extensions written 10 years ago that we want to use in mock, and they're used all over the code base. In our case, those static methods are just our big decimal utility functions. So a different approach would be to create a non-static wrapper around our static methods, which I'll do now. Which will contain two methods. And now inside our consumer, instead of directly invoking the static methods, we'll go through our wrapper first. I'll just add a constructor. And here, instead of invoking the static methods, we'll just call the wrapper functions. And now using this approach, we can mock the methods of the wrapper class and make sure that they do what we expect them to do. So just go to our tests again. And we need a mocking library for these purposes. So I'm going to go to Maven again and download Mockito into our project. Okay, so now we can make sure that we can mock our wrappers methods. First, we create a mock for our big decimal wrapper. And give it to our consumer. Next, we create a dummy return value. And finally, we make sure that the dummy return value gets returned when a wrapper's integer method gets invoked. All that's left is to check that the result of the consumer is the same as the dummy return value, since the consumer calls the wrapper by proxy and we have mocked the wrapper. The test passed as expected. Just like in the Kotlin example, we will take a look at the other common mocking operation, which is verifying that the method has been called. I'm going to create a new test for that. First, we need a mock for our wrapper, just like in the test above. Next, we instantiate a consumer with our mocked wrapper. Next, we invoke the consumer with our test input value. And finally, we verify that invoking the consumer correctly proxies the test input to the wrapper. And the test passed successfully. If we comment the consumer method out, the test fails as expected. Thanks for watching and see you in the next video.